Okay, so we have 0 to pi over 2, 0 to 5 of r sine theta e to the what? I don't know why it does that sometimes, but it does. Then it pop back, yeah. R
It's surprising how
cosine theta.
so close.
Yeah. Handwriting is pretty neat. Okay, so this one, yeah, it is a little challenging. Anybody have any thoughts as to?
Well, I tried approaching it with tabular, and then it just got bigger and bigger.
Well, hold on. What are we first integrating with respect to?
R.
We're first integrating with respect to r. So let's clean it up just a tad here. One thing we can do is make that r squared and just get rid of the r right there. That's one thing we could do. And keep in mind, it's not that I don't like tabular, it's just I don't have much practice with it, so I'm not going to be able to guide you through it much. I'll try to find some time.
Can I walk you through it?
Not right now. Let me learn it first so I can actually have an intelligent conversation with you. Okay, so if we're not going to use tabular, we need to integrate with respect to r. What would be the easiest way to do that?
Parts.
Is it by parts? Is that the easiest way to do it? No, do that as long as you switch the order. That's a really cool observation. So you're saying do this instead? Why were we really careful not to do that before?
Because you don't have your numbers.
Yeah, exactly. We actually have two definite integrals, right? We have two definite integrals. So if we do it this way, I actually like this a lot. Very cool observation. U is equal to r cosine theta. Yeah, so d is equal to minus r sine theta d theta. So d theta is equal to du over negative r sine theta. So now we get to substitute. 0 to what?
Actually, it has to change.
Yeah, you better change it.
R to nothing.
It's from r to nothing? It's from r. Why is it r? Can you explain that to me? Why is it r right there?
There's only going to be one integral.
I understand, but
Plug in 0, it's cosine 0, which is 1, and 1 times r.
that's what I wanted you to say. There it goes. Okay, great. And if you plug in pi over, what's cosine of pi over 2? Is 0. 0 times r is 0. I'm just doing this properly. We end up with sine theta e to the u times du over negative r sine theta dr. What nicely goes away for us? Yeah, well, the thing, is it okay if the r sticks around?
Yeah.
Yeah, what's the thing we really have to get rid of?
That's
That sine theta. Well, you could just say theta, right, exactly. We really want theta to get out of there. But can you cancel just the sine? No, you can't. So one of the r's cancels. So you're left with what? Negative 0 to 5, 0, not 0, r to, well, we haven't integrated yet, r to 0 of r e to the u du dr, right? Is that what we have? Did I simplify that right?
Yep.
Seems okay. I like that. We're now integrating with respect to u. Therefore, we treat r like a
Constant.
0 to 5 of what?
R to u.
R e to the u from r to 0 dr. We have to be careful to keep that along for the ride.
That's r minus.
Yeah. So that's going to be r e, oh yeah, r e to the 0 minus r e to the r dr. R. Pirate math, pirate multivariable, and that definitely was r minus r e to the r dr.
R.
R. Okay, is that correct? Is that okay? You know, just for my own sanity, I generally like to just break it up into. Oh, we don't have to break it up into two.
Put the minus sign back in and just make it r e r minus r.
Okay, that's totally okay. I like that. Minimize the negative signs. That's cool. I like that. R e to the r minus r dr. So now we need to integrate this thing. What's the trickier one to integrate? You've already done this exact integration before. Which one?
The first one.
The first one, the r e to the r.
Well, we've done the second one too.
We have several hundred million times. That's correct. As a given practice. Absolutely. Let's just pause this here to get it set up. 0 to 5 of v, which is what? E to the r dr. And what was this from here? We knew that was from, this is the integral of what? U times v, right? Is that what it goes from, right? Sorry, u dv. Thank you, yes. 0 to 5 of u dv. Thank you. Is equal to that. Yeah, okay. So we can evaluate this now. Yay, yay. What's it become? We're plugging in for 5, right? Minus what? Minus 0, right? Minus e to the r from 0 to 5, right? 5 minus e to the 5 minus 1. So you end up with 4 e to the 5. 4 e to the 5 plus 1.
Wait, we forgot about the other part.
I know. I'm scrolling back up here. So if we scroll back up here, you end up with 1/2 r squared from 0 to 5. So you end up with 25 over. So you're subtracting that, right? So your final answer is going to be 4 e to the 5th plus 1 minus 25 over 2. So you're going to get, let me see if we can match it. Minus what? Yeah, they usually have the improper fractions. Let's see if we actually agree here.